All right, welcome everybody. Here's a look at worksheet number 2. So what I plan on doing is I'm going to go through the 4 examples here, examples 1, 2, 3, and 4. And based off of those examples, you're going to answer the questions that say solve. You can print out a blank copy of this if you have access to a printer. I'm going to make a copy of this available to you on Google Classroom. If you don't have access to your printer, you can write this out on scratch piece of paper, and you're ultimately going to submit your answers on the Google form that is also corresponding to this worksheet. Okay, so let's take a look. Example 1 says, how many grams of hydrogen are used when 2.3 moles of water are produced? So first of all, like we practiced before, identify what information is given to you. And I'm given 2.3 moles of water. Okay, and I want to convert moles of water to grams of hydrogen. So now I'm going from moles of one thing to grams of something completely different. Okay, so we're going to set it up just like we've practiced before. Let me see here. Okay, so the first thing we need to do here is balance the equation. We always want to make sure that our equations are balanced because that's going to give us the best or the actual ratio of molecules or compounds in this formula. So I've got H2 and O2 producing H2O. You can practice the box method just like we've used before. This one is actually pretty straightforward. I've got 2 hydrogens here, 2 oxygens here, and 2 hydrogens, 1 oxygen. So when I'm looking at this, I've got 2 oxygens here. 2 hydrogens, 2 hydrogens. That matches up. Here I've got 2 oxygens and 1 oxygen. So I can fix that by putting a 2 in here as my coefficient for water. And what that does is now I've got 2 oxygens, but it gives me 4 hydrogens. So an easy fix to correct that is to put a 2 in front of H2, hydrogen gas, and now my equation is balanced. So I've got 2 times 2, that's 4 hydrogens here, 4 hydrogens here, 2 oxygens here, 2 oxygens here. My equation is balanced. Now in this space here, it's actually a 1. We don't normally write the 1s, but just so you know, it is going to be a 1. So my coefficients are 2, 1, 2. So now I can set up my T-chart. Okay, here's my T-chart. I'm going to write in what's given to me, which was 2.3 moles of water. So 2.3 moles of H2O. Okay, now remember I always have to bring down the units. So moles of water, I'm going to rewrite down here. Moles of water. Okay. And then I'm going to convert moles of water. I need to go to grams of hydrogen. But if I've got moles of one substance, I cannot convert to anything else unless I go from moles of one substance to moles of something different. So right here, this is going to be my mole ratio. I'm going to go from moles of water to moles of hydrogen, and this is hydrogen gas, so I'm going to write H2, and it's written as H2 in my formula right here. Okay, so I'm going to add a little note here that this is my mole ratio. So now look at the coefficients. What's your coefficient for H2? It's a 2. What's your coefficient for H2O? It's also a 2. So now I've got moles of hydrogen. Now I need to continue moving because I am trying to convert to grams of hydrogen, so that's an additional step. So just like always, bring down the unit. In this case, it is moles. There you go. Moles of hydrogen. And I want to go from moles of hydrogen to grams of hydrogen. Now I can go from moles to grams if it's the same substance. So moles of hydrogen gas to grams of hydrogen gas, I can do that. Now this is my mole conversion. This is my molar mass conversion. So I know that in 1 mole of hydrogen gas, I need to figure out how many grams that is. So let me add a little note here that this is my molar mass conversion. And I can find molar mass by taking the mass of 1 hydrogen, which is 1.008, and multiplying it by 2 because there are 2 hydrogens in hydrogen gas. So 1.008 times 2 gives me 2.016. So that gives me right here 2.016 grams of hydrogen. Now I do the math. I take 2.3 times 2 times 2.016, all divided by 2 times 1. So I'll write that out here for you. 2.3 times 2 times 2.016, all divided by 2 times 1. We don't really need to multiply by 1. So 2.3 times 2 times 2.016, all divided by 2, gives you 4.64 grams of hydrogen gas. So now I want you to use that example to solve the question below. So we're going to go ahead and move up. Let's look at our second example here. Okay, so it says how many moles of carbon are used to produce 4.3 moles of CF4. CF4 is carbon tetrafluoride. Carbon tetrafluoride. I'll add that up here for you guys. This is carbon. It's tetra because there are 4. Fluoride because this is fluorine. So Fluoride, carbon tetrafluoride. So just like before, we've got to make sure that this equation is balanced. So let's look. I've got 1 carbon here, 1 carbon here, 2 fluorines here, 4 fluorines here. So that tells me it is not balanced. So I want to add fluorines to the lowest side, okay, which is on the left. It's the reactant. So I've got 2 fluorines there. An easy fix is if I simply just add a 2 there. 2 times 2 is 4, which gives me 4. I've got 1 carbon here, 1 carbon here. Everything else is balanced. So I would essentially write a 1 and a 1. So my coefficients are 1, 2, 1. So now I want to figure out how many moles of carbon are used to produce 4.3 moles of CF4, carbon tetrafluoride. All right, so what's given to me? Well, I'm given moles of carbon tetrafluoride, and I want to figure out how many moles of carbon there are. So this is given, and moles of carbon unknown. Okay, set up your T-chart. All right, so I'm going to start with what's given to me, 4.3 moles of CF4, carbon tetrafluoride. So 4.3 moles of CF4, and then I bring down my unit, moles of CF4, and I want to convert from moles of CF4 to moles of carbon. So I can go from moles of one thing to moles of something different because of the mole ratio. So I can go from moles of CF4 to moles of carbon because this is my mole ratio conversion. Okay, so now I look at my equation. My moles of carbon, I've got 1. My moles of CF4, I've got 1. So my mole ratio is simply 1 to 1. Oops. Hang on, technical difficulties. All right, there you go. So 1 to 1. So now I calculate. Got 4.3 times 1 divided by 1. Doesn't really change anything. And I get 4.3 moles of carbon. So now with that example, I want you to try to solve for the answer or for the question below. All right, let's look at example number 3. All right, so example number 3, it says how many grams of CO2 are produced using 24.2 grams of O2? All right, so let's identify what is given to me. So I'm given 24.2 grams of O2, and I want to convert to grams of CO2. So this information is given. This is unknown. So now I want to go from grams of one substance to grams of something different. Okay. So before we can do that, let's figure out if our equation is balanced. Here I've got CH4 plus O2 produces CO2 plus H2O. I've got 1 carbon here, 1 carbon, 4 hydrogens, 2 hydrogens, 2 oxygens, 1, 2, 3 oxygens. Okay, so an easy fix here. And again, I recommend that you go ahead and try the box method. You can go and pause the video, perform the box method on your own piece of paper or scratch paper or this worksheet if you print it out, and come back to check your answers. All right, so the easiest way to do this, if I put a 2 here, that gives me 4 oxygens on the left. And if I put a 2 here, that gives me 4 oxygens on the right. So now let's look. I've got 1 carbon, 1 carbon. 4 hydrogens, 2 times 2 is 4 hydrogens. 4 oxygens, 2 oxygens here, 2 oxygens here, giving me 4, so my equation is balanced. So my coefficients would be 1, 2, 1, 2. All right, set up our T-chart. Okay, so I'm going to start with the information that's given to me. It was 24.2 grams of O2. So 24.2 grams of oxygen gas. Remember to bring down the unit, so grams of oxygen gas. Now, grams cannot convert to anything else other than moles. So I can only convert to moles of the same thing because this is my molar mass conversion. Okay, which means 1 mole of O2 is equal to how many grams of O2? Well, oxygen is 15.999, and I've got 2 of them, which gives me 31.998. So 1 mole of oxygen is equal to 31.998 grams of oxygen. So now I'm at moles of O2. I need to go to grams of something completely different, so I'm going to keep going. So now I'm going to bring down the unit, moles of O2. Now, here is my chance to go from moles of one thing to moles of something different. I want to go to carbon dioxide. This is the only opportunity that I can do so because of my mole ratio, so CO2. So when I look at my equation, I've got 1 mole of CO2 and 2 moles of O2. So my ratio is 1 to 2. 1 to 2. Again, this is my mole ratio. All right, so I'm at moles of CO2, so I'm getting closer. I ultimately want to be at grams of CO2, so I'm not done yet. So another step, bring down the unit, moles of CO2. Now I can go from moles of CO2 to grams of the same thing. So now I'm doing another molar mass conversion. So I know that my molar mass conversions, my moles are always 1. And in 1 mole of CO2, you got to figure out how many grams of CO2 you have. So down here at the bottom, carbon has a mass of 12.011, and I've got 1, which is 12.011. Oxygen is 15.999, and I've got 2 of them in CO2, which gives me 31.998. And when I add those 2 together, you get 44.009. So 44.009 grams of CO2. So now you do the math. 24.2 times 1 times 1 times 44.009, all divided by 31.998 times 2 times 1. Okay, so when I multiply everything across on the top, I get 1065.0178 divided by everything on the bottom, which is 31.998 times 2 times 1, gives me 63.996. So when I divide those two, you should get an answer of 4.3. 4.3 grams of CO2. All right. So now we're going to move on to our last one here. Actually use that example to help you answer the question below and enter your answer into Google Forms. And our example number 4, let me zoom in here. I want to know how many moles of oxygen are needed to produce 10 grams of water. All right, so again, make sure that your equation is balanced. I'm given 10 grams of water. I want to know how many moles of oxygen that is. Step 1, balance your equation. Pause the video right now. I want you to try this one yourselves using the box method. Okay, so I'm not going to show you the box method on here because I don't have the space for it. I'm just going to write in the coefficients. Hopefully you pause the video and you were able to determine your coefficients yourself. If you haven't, please do so before we proceed in the video. So the coefficients for C3H8 are 1. There are 5 molecules of oxygen gas. There are 3 molecules of carbon dioxide and 4 molecules of water. So my coefficients are 1, 5, 3, and 4. So again, I'm given 10 grams of water, and I want to convert to moles of oxygen. All right, set up your T-chart. Start with what's given, 10 grams of water. Bring down the unit, grams of water. Now grams can only convert to moles of the same thing. Molar mass conversion. Okay, so that means 1 mole of water is equal to how many grams of water? So you have to add in, factor the mass of hydrogen plus 2 hydrogens plus 1 oxygen. So 1.008 times 2 equals 2.016. Oxygen is 15.999 times 1 is 15.999. And when I add those two together, I get 18.015 grams of water. Now, I need to take this one step further. So moles of water, and now I use my mole ratio to go from moles of one substance to moles of something different. So when I look at my equation, my coefficients, I've got 5 moles of oxygen and 4 moles of water. So my ratio is 5 to 4. So 5 to 4. So now I do the math. 10 times 1 times 5 is 50. And then 18.015 times 4 is 72.06. And when I divide those two, you should get an answer of 0.694 moles of oxygen gas. So again, this is example 4. Use example 4 to answer the question below and submit your response in the Google form. If you have any further questions, send me an email, send me a message, and I'll try to take care of them as quickly as I can.